Hello, this is me working through the section 6.1 worksheet. Question 1. Describe the general shape of an exponential function. I'm actually going to leave you guys to do that one on your own. Question 2. F of x equals 2 to the x minus 1. So first I'm going to go through. A is equal to 1, B is equal to 2, C is equal to 1, H is equal to 0, and K is equal to negative 1. So our starting point is H comma K plus A. H was 0, so 0. K plus A was also 0, so our starting point is 0, 0. Our horizontal asymptote is at y equals K. Since K is negative 1, that's y equals negative 1. And last but not least, we need a second point. I'm just going to plug 1 in, so f of 1, which is 2 to the 1 minus 1, which is 1. Our second point is 1, comma 1. Start out with the horizontal asymptote at y equals negative 1. Plot our 2 points, 0, 0, 1, 1, and then make the exponential curve. And there's our graph. Number 3, A is equal to 1, B is equal to 1/3, C is equal to 1, H is equal to 1, and K is equal to 0. Starting point, H comma K plus A. So we get 1 comma 1. Horizontal asymptote, y equals K. So we get y equals 0. And then our second point. I am going to choose 0. So f of 0 equals 1/3 to the 0 minus 1, which is equal to 3. So our second point is 0, 3. Again, start with the horizontal asymptote. Plot our 2 points. And try to connect them with an exponential curve. There we go. Question 4. Graph the following. So first of all, I am going to rewrite this one. So that's in standard form, because that x plus 1 over 2 is the same thing as 1/2 times x plus 1 in parentheses. So then we have that A is equal to 1, B is equal to 10, C is equal to 1/2, H is equal to negative 1, and K is equal to negative 20. So our starting point, which is H comma K plus A, is negative 1, negative 19, horizontal asymptote, which is y equals K, which is y equals negative 20, and then a second point. I will do f of 1, which equals 10 to the 1/2, 1 plus 1, minus 20, which is negative 10. Now here, each tick mark will represent 2. So we're going to 20, 20 instead of 10, 10. So start with the horizontal asymptote, y equals negative 20. Okay, first point, -1, -19. And then second point, nope, sorry, that was the wrong point, is 1, -10. There we go. Connect that with an exponential curve. Okay, 5. Again, I'm going to rewrite it just so I can obviously see what my k is. So this is the same thing as -1 times 1.25 x minus 2 plus 1. So a is equal to -1, b is 1.25, c is 1, h is 2, and k is 1. So we get our starting point, h comma k plus a, which is 2 comma 0. Horizontal asymptote, which is y equals k, so we get y equals 1. And then our second point here, what would be a good point? 3. Equals -0.25. Horizontal asymptote, y equals 1. And then we have 2, 0. And then 3, -0.25. And you have a shallow exponential. Now for number 6, we're going the other way around. So the first thing, instead of identifying what A, C, H, and K are, I'm going to identify the properties. So the horizontal asymptote is y equals -3. This implies K is equal to -3. Next, to get a starting point, I'm going to use 0, -1 as my starting point. So that implies that h is 0 and k plus a is -1. Well, since k is -3, that implies that a is equal to 2. Now we just need to find out what c is. To find c, you have to pick a second point. I'm going to pick the point 1, 1. So our equation so far is y equals 2 times 2 to the c times x minus 0, so just x, plus k, so -3. And now I'm plugging in the point 1, 1, so we get 1 equals 2 times 2 to the c minus 3. Add 3 over to both sides. Divide by 2, we get 2 equals 2 to the c, which implies 1 equals c. So our equation here is 2 times 2 to the x minus 3. So here again, I'm going to start with the horizontal asymptote, which is y equals 0, which implies k equals 0. And then pick a starting point. It does give us that fractional point, but I'm not going to use that as my starting point. Instead, I'm going to use 0, 3 as my starting point, which implies h is also 0, and then k plus a is equal to 3. So and since k is equal to 0, that implies a is equal to 3. So our equation so far is y equals 3 times 2 to the cx plus 0, so just cx. Now I'm going to use that fraction point it gave us, so we get 3/2 equals 3 times 2 to the 1/2 c. Multiply both sides by a third, so you get 1/2 equals 2 to the 1/2 c. 1/2 is the same thing as 2 to the negative 1. So we get 2 to the negative 1 equals 2 to the 1/2 c. Or in other words, 1/2 c has to equal negative 1, so c equals negative 2. So our function is 3 times 2 to the negative 2x. And that's it for question 7. And now for the remaining questions, because they are challenge questions, I am going to leave that as a question to answer in class tomorrow. Thank you. Have a good day.